HSS. The first part was done 2 weeks ago, where we started talking about started talking about the options that we have in HSS, and this week we'll continue with the next few options that we haven't talked about yet, that I haven't showed you yet. And the next webinar that we'll be doing will actually be advanced HSS, or I like to actually call it practical HSS, where we'll be doing we'll be taking parts that we may have difficulty machining them, and we'll show exactly how with HSS we can actually get the surfaces finished exactly the way we want to in difficult situations. But like I said, today we're going to be doing part 2 and finishing off the other options that we have in HSS. Now, as in every webinar, you will be able to ask questions during the webinar. All you have to do is click on raise hand, and when you click on raise hand, sorry, you don't see my screen. Okay, now it's better. Okay, when you click on there we go. After you click on raise hand, you write in the questions area your question. At the end of the question, you just click on send. And at the end of the webinar, I'll go through any questions you may have and try to answer them with the best of my ability. Okay, so let's get started. Like I said before, we had done HSS, started with our first few options, just to go over them quickly again. Sorry, just a moment. Just to go over them quickly again, if I were to open up HSS, we had the options of parallel cuts, parallel to curve, and parallel to surface, parallel to curve, and parallel to surface. This week, I'm going to go through these options that I left over here, plus some other options that we have inside HSS as well. Okay, we'll start off with the part that we see on our screen over here. And what I'd like to do in this particular operation is to mill out this surface and this surface. And the toolpath that I'd like to build on these surfaces is going from one end to the other in this direction, from here to here, and the same thing on that surface as well. So I'll start my HSS operation, and I'll choose the option of perpendicular to curve. Now, the surface that I'd like to work on, as I said before, there are actually two surfaces. I'm going to want to work on this surface as well as this surface. I've chosen those two surfaces. Now, I want the tool path to be perpendicular to a curve. The curve that we want it to be perpendicular to is this curve over here. It's going to be perpendicular to that curve. Okay. The tool that I'll be using, I'll just choose my 6mm ball end mill. And without going into anything else right now, I'm just going to click on Save and Calculate, Simulate. And if I run my toolpath, let me just run it a little slow, you'll note that it's actually working on each surface, going back and forth from one side to the next. Let's just go all the way up, all the way to the very end. We'll do this very quickly. And it was done. Now, looking at this, I'm saying to myself, you know what? This is not really what I'd like to, it's not really the best way to machine this. I would prefer actually, forget about these clearance steps, but I would like to actually finish off one surface, and then when you finish that surface, go to the next surface. Not go back and forth, because there's a whole bunch of waste time over here. You're wasting a lot of time by doing this way. So one way is just to do two separate operations. First do an operation on this surface and then do a copy operation on the next surface. Or we can do the following. In our toolpath parameter area, we have the option of sorting. In the tab of sorting, we can go zigzag, which I'm fine with at the moment, cut order. What I'd like to deal with is machine by, where we have two options, lanes, where if you see in the diagram, it goes just back and forth, and even if there's a split in the surface, it just goes back and forth along the toolpath as shown over here. And that's exactly the way we saw it working a couple of minutes ago. I can also change this to regions, to work in different regions. In other words, if I have a region such as this one, in other words, that's a different surface altogether, it'll work on this area, then this area, but it will not go onto this area until it finishes this area over here. Let's take a quick look at the simulation now. And this time, you'll see that the tool is working on one side. When it finishes that one side, it'll work on the other side. So without making a separate operation, I can do this all in one operation, just change it into different regions to work in. By the way, if I didn't mention this before, the webinar is being recorded and will be available for viewing tomorrow on our website. If I were to go into my website just for a moment, you can see that we have on our website where it says webinars, webinar recordings. And all the recordings of previous webinars are placed over here. And the one that I have, that I'm doing right now, will be here tomorrow as well. Okay, now that I've mentioned it, let's continue on now to the next part. In this part we have over here, this is a typical case that many people sometimes run across, where they have a fillet as shown over here on this edge. Now, people would think to themselves, maybe, I'd like to work with a concave type of radius tool, but that's not really going to work over here. One, because you can't really do it this way, going up and down like that. Even if I had it lying on its side, I would still have the problem over here. But this can easily be taken care of in HSS. Let me open up the HSS, and the option that I'm going to use over here in HSS is morphed between two boundary curves. What's actually going to happen is as follows. We're going to take the part. We want to work on these surfaces going around. And I'm going to tell it I want you to work between these curves over here, the top curve and the bottom curve. It'll actually start off with the shape of the top curve and then finish off with the shape of the bottom curve, making equal distribution of the tool path along that surface. Let's see exactly how this works. If I were to go to my geometry, I already created a geometry, so let's just take that geometry. The geometry in this particular case are the surfaces of the radius itself on the part as shown over here. And our start edge curve is going to be this curve as shown over here, this edge, the top edge, as shown on the part over there. And our bottom curve, our end edge curve, will be, sorry, just a moment, there we go, will be this one over here. So it's basically going to start according to the shape of the top curve and then finish off according to the shape of the bottom curve. You'll see exactly what we're talking about in a moment. I'll choose my tool. In this particular case, it will be a 4mm ball and mill. And in my toolpath parameters, let's make this a really small step over, let's say 0.1. Let's run our simulation. And I'll run this I'll run it the way it is right now. You see the tool is going back and forth exactly on the radius. Okay, let's do this quickly. and it works perfectly well on the radius, going from the first shape to the bottom shape over there, touching every part of that radius. Now, of course, as far as the ends go over here, when it goes over from one pass to the next, that we can deal with in our links. First of all, in our links, I'm just going to have my use lead in and use lead out for my start and end. And my lead in, by the way, default is tangent in this particular case. And as far as my links goes, links between slices, I'm going to have that as, I will use blend. Let's run our simulation again. As you can see over here, we have also our arc going in, as shown over there. And at the end, we have our arc leaving the part. And we also, of course, have the blend at the end of the toolpath as shown over there. Now, let's take a different part where I'm also going to use the option of morph. But this time, the morph option I'm going to use is called morph between surfaces. Let's take a look at the operation itself. If we're taking a look at this part, in this case, I want to machine these surfaces around here, going around the entire part as shown over here. So this time, I'm going to use the option in HSS, morph between two adjacent surfaces. In many cases, it's easier to pick an adjacent surface rather than picking the edge. In this case, the adjacent surface is the top surface over here, which covers this entire area over here. So it's a lot easier picking that surface than picking these edges over here. Excuse me. So let's go into our geometry. I already created my drive faces. My drive faces in this case are these surfaces around the part as shown over here. And my start edge surface, as I mentioned before, is this surface over here. And my end edge surface is the bottom over here. And I included over here these surfaces going around there as well. My tool that I will be using will be a ball end mill of 6 millimeters. And let's just go into our toolpath parameters. And so this work is actually a pretty large part. So let me just put it at every 2 millimeters. Run my simulation. First, it's doing a calculation. It'll take a couple moments because this is a relatively large part. Which gives me a quick chance to drink a glass of water. Okay, let's run our simulation now. And I'll actually run it relatively slow so you can actually see what's going on. Note that first of all, it's starting off at the very top, going according to this shape as shown over here. That's the shape it's working on. Now, as it goes further down, note, now let me stop this now. It's starting to change its shape according to this area. This is the actual morphing that we were talking about, where it goes according to from the first shape towards the second shape over here, which makes for an evenly distributed tool path along the entire part itself. Now, when I said 2 millimeters, by the way, distance, the 2 millimeters distance is the largest distance that you'll have between your tool paths. Let's finish this off now until the very end. You see as it's changing its shape until it gets to the very, very end. And then it finishes the part. Now, one more thing I'd like to deal with is over here, that sometimes you have areas of surfaces where they're not completely touching exactly the way they are. So there are gaps in the toolpath, or the toolpaths are too close to one another for whatever reason. So in this case, I'll just go back. And since we're talking about our gaps, I'll go into link. And we'll go into large gaps. Large gaps, in this particular case, I'll just tell it, follow the surface. Just go along the surface that you see over there until you can connect to your next area. Again, I'll run my simulation after I do the calculation, which you'll see in a moment. And run the simulation now, and this time, again, you can see it changes its shape as it's going further down. And when it gets to the end, it'll go actually follow its surface as shown over here. Note, this is really a perfect toolpath as we see it. Okay, you can see it from all sides. One entrance point, one exit point, and that's it. Okay. Now, let me run my next operation, my next part, and let's do this one. And in this part, I want to show the option of projection, or some people actually may call it option of engraving, because this can be also used for engraving. Okay, there are two operations I'm going to do here. I'm going to first start off with the projection of using a curve that's on the surface itself. I'll start HSS. We have the option of projection. The geometry, in this case, the dry surface will be this surface over here. And the projection curve that I want to use right now is this one going around the edge of that surface. So as far as my projection curve, I'm going to create a new one. I don't really need the old one. I'm just going to use that edge over there. That's my projection curve. The tool that I will be using will be an 8mm ball end mill. And that's it. Let's just do a quick calculation. And what's actually happening is the center of the tool is going on that tool path. Let's run this a little slow. And you can see the tool goes down, works on that tool path going around the part itself. Now, let me run this doing solid verify. And you can see that's going around the part there. Now, if I wanted to actually engrave into the surface itself, all I would have to do is, if I can go into geometry, I would click on drive surface offset and give it a negative offset into the surface. Let's say 0.5 millimeters. Run my simulation. And as you can see now, it actually engraved itself into the surface itself on that edge that I had chosen. Now, this is true right now for an edge that was on the surface itself. What about something, an edge, that's not on the surface? For example, hard to see it right now, but I'll make it lighter in a moment. I have this little circle over here. Okay, now the circle is not touching the surface at all. It's actually in the air. If I was to hold it like this, you can see that it's in the air over here. Okay? So what I'm actually going to do, I'm going to use the option of projection where it'll actually project itself onto the surface. The tool path will project itself onto the surface itself. Let's take a look at how this works. Again, I'll use the HSS operation. And my geometry will be the exact same surface I had last time. My curve, however, my projection curve, will be that circle over there. Excellent. Now, I'm going to choose my tool, my 8mm ball end mill, and let's do save and calculate and see what happens. What do you see? Absolutely nothing happened. Okay? Why is that? Well, note, first of all, let's take a look at HostCAD. You'll note that the tool will go down and give us a tool path, but the tool path is only being done over here. Why? Because this area is closer to the surface. If I were to go into my geometry area, you'll note there's another field over here called maximum projection distance. It's projecting itself onto the part itself. However, it'll only project itself as far as this distance. So if the distance at the edge of this curve is more than 0.1 millimeters, which obviously in this case it is, it won't machine there. This area was closer, so it did work over there. But this area wasn't. Let's just change this now to 0.5. Let's see what happens now when I run my toolpath. You can see now it's going around the entire circle, and you can see according to the toolpath that it's actually projected itself onto the part itself, onto the surface itself. If I wanted to engrave that circle over there, simple. Geometry, drive surface offset, let's do 0.5 millimeters. Sorry, not 0.5, but minus 0.5. Save and calculate. Run my solid verify simulations. You can actually see the engraving into the part itself. And as you can see, it engraved itself, projecting itself onto that surface as shown over here. Okay, so that's the option of engraving. Now, I'd like to load another part that we have over here. And on this part, we can actually deal with a problem that we may have every now and then with parts. What I'd like to do is machine these surfaces around over here. These surfaces are on a little bit of an angle. If I were to look at the top view over here, you can see that it's actually angled going down. Turn slightly this way, you can see that it's really an angle. All of these walls are at an angle. Okay, so I'm going to use HSS to machine it. I'm going to use a simple operation of HSF of parallel to constant Z. Parallel cuts constant Z. My geometry, I actually have it already made, so let me just choose it over here. My geometry are these faces over here. And I'm going to use an end mill, say a 3mm bullnose tool. Okay? Levels, toolpath parameters. Just going to leave everything just the way it is right now. Run my simulation. And as you can see, it does the proper toolpath going around the part. You can see that it did a radius over here. Okay? And it happens to be in this case that the radius that we have over here is larger than the radius that I used this time. So it made a really nice curve over here. Now what happens, however, if the tool that I have is larger than the radius that I have in the corner? Well, let's take a look. I'm going to use a larger end mill. Instead of 3, I'm going to use a 6mm bullnose. Sorry. A 6mm bullnose. Run my simulation. And let's take a look at what we see right now. What we see right now is when it gets to a sharp corner, which is what this is, it has to do a sharp corner. Now, because these are surfaces, not a solid, it doesn't recognize anything that's around it. The way it works many times on surfaces, which in this case I call it a little bit of a catastrophe, is that it comes to the end over here, it comes to the corner, and then in order to get into this way, it just has to somehow swing itself around. Which, of course, if I were to run my solid verify, you can see it actually gouging into the part itself, which is not what I want. So we have a simple tool that will deal with this type of situation. If I were to go into my geometry section, we have the option in geometry, and this is true, by the way, in every single one of our HSS operations that we have something called round corners. If I were to choose the option of round corners and activate it, I can say, okay, those sharp corners that you had over there, change them into a smaller corner. Okay? So what actually happens is that you're going to get a radius instead of a sharp corner. If I have a radius, that loop will not be created. Let's take a look at the simulation now. And I'll run this in HostCAD. You can see that the toolpath now is not going across as we saw before, but rather going around according to that 0.1 millimeter. If I were to run the simulation again, this time running the solid verify, you'll see that the tool path is being done. Obviously the corners are not being touched over here because the tool is larger than the corners itself, but that 0.1 millimeter radius that I added in over there prevents it from having a sharp corner, so therefore it moves along that tool path as shown over here. Now, there's one more option that I'd like to show you on this particular part, and that's what to do when you have a part that has an undercut. If I were to take a look at this wall over here, this wall actually works as an undercut to the top surface. Now I'm working right now on a 3-axis machine where I don't have the comfort of flipping it around and putting a different end mill, just working towards this flat. I have to work either in a different, if I want to hold it different, I can put it in a different holding fixture, or if I want to do it in the same operation as I'm doing the rest of the operations here, we can use HSS. HSS allows you to work on undercut surfaces. Obviously, though, when you do that, you have to have the proper tools that can work on an undercut. For example, T-slot. Let's open up a new operation. Again, I'll use constant Z. My geometry in this case will be this surface over here. Okay? And the tool that I will be using will be a slot mill, as shown over here. Let's make the arbor diameter at 10 millimeters. Okay, as the arbor diameter. The cutting length is 4 millimeters with a 2 millimeters radius on the corner. So it actually looks almost like a ball end mill at the edge. It's completely round at the edge over there. Obviously, this is a T-slot. I happen to know that the distance between this edge and this edge going in the Y direction over here is a total of 6 millimeters. So I have no problem with this kind of a tool with these measurements that I have over here. Okay, let's select the tool. We have our toolpath parameters. We have our links. Let's just do a quick, an easy, simple lead in and lead out. Run my simulation. And as you see, the tool worked on those surfaces. Okay, actually the tool path is pretty far apart. That's because I didn't make any changes as far as the toolpath parameters, as far as the step over. I'm going to leave it at that because that's not what I want to show you right now. Now, what happens if I have a tool and instead of it being 10 millimeters with arbor diameter, I'm going to make this 16 and this 16 as well. So in essence, what I'm getting here is a tool that looks more like this. Okay, now when I have a tool that looks like, what do I actually have here? I have a 24 millimeters as far as diameter and 16 millimeters here. That means there's 8 millimeters difference between the two. It's 8 millimeters smaller. That means from the edge until the shank itself on one side, there's only 4 millimeters. And this edge over here, as I said before, is 6 millimeters apart. So the shank is actually going to touch that part. Let's see exactly what's going to happen. I'll run the simulation, and of course I'm going to get a crash notification. Okay, what actually happened when it got to this edge over here, and let me do this again from the beginning. You see what happens? It went down perfectly well, but then it's hitting now this area over here. So what we need to do in this particular case is very simple. We'll go out, we'll continue on down to gouge check. Now in gouge check, I'll enable my gouge, and what I'm going my gouge check, and I wanted to do is actually tell the shank and the arbor not to touch this surface over here, which actually goes to the very edge, which is fine. I can actually use this if I want to also, but just simply use this one here on top. We're talking about now the check surfaces, so let's do one on the check surface over here. Now, what to do? Let's just leave out gouge points. In other words, just stop working. Don't look for any more points to machine on. Okay. Again, we'll run our simulation. And let me just do this a little slowly over here. Looking at the side view, if I can over here. Of course I can. To put it there. Zoom in over here. And let's take a look what's happening. The tool right now is going in. The tool tip can come over there. It's fine, not a problem. Now it's going down each surface. Now look what happens. When it gets to that edge over there, it's still touched. Why? Simple. Let's go into the operation itself. The arbor also has to be taken care of. The arbor can't touch it. The tool tip I'm not worried about, but it's the arbor that I have to make sure that it doesn't touch that surface. Let's go back over here. And again, we'll run our simulation. You see the tool coming down. Let me zoom in a little. This tool comes in. And then when it gets to that edge over there, note it starts moving itself away, leading out, and then going back up and finishing, doing the most that ink can do. And by the way, if you want, you can always go into stock to leave to give a little more of a clearance area between the shank, between the tool shaft arbor, and the material that you don't want it to gouge. Okay, I'm ready now for any questions that you may have. Remember that these webinars are recorded, so you'll be able to see them later on our website. I'll give you another moment or two to write down any questions you may have. Okay, I guess Okay, if you have a question, Arthur, please write it down in the question area. You're welcome, Irma. Remember, if you have any questions to ask, besides raising your hand, write it down in the area of questions. And then click on send, and then I'll be able to answer all the questions that you may have. Okay, now if anyone, by the way, if anyone wants any of these parts, just send me an email to webinar@solidcam.com, and I will send these parts to whoever wants them. This way I have your email directly, I know exactly who wants what. Just send an email to webinar@solidcam.com, and I will return the parts to that email that you have. Okay, and if you need any more further communication with me, you can do that later on. You can always drop me an email, and we'll try and get together, if I can, a discussion, if whoever needs a specific discussion. Okay. Thank you very much for joining the webinar, and see you next week on our next webinar, where we'll be discussing the options of HSS again, but this time will be more advanced options in HSS, and showing you exactly how to deal with specific situations that you may have. Okay, thank you very much. Take care, everyone, and have a great rest of your day, and have a great weekend as well. Bye-bye.